time we have to do that. So today's presentation is a lot on automation, since Gradle is one of the things that helps us out quite a bit with that. So let's talk a little bit about Gradle. So one of the things that got me into doing an automation talk is I love delivering software. I like to do it a lot, multiple times a day if I can. One of the things about delivering software that probably many of you know is getting it out in front of users and having people use it is probably one of the more exciting things that we get to do in the day, because then we get to see people using it, we get to see it working, and we get to see it benefiting our company. And it's something that at the end of the day is what we get to hang our hat on. If we're only doing that once a year, once a month, sometimes that gets a little bit nerve-wracking. But multiple times a day, people actually do that? Here, we have a bunch of people that say they are doing it, so that's pretty exciting. Most audiences, I don't think we've got a lot of folks doing continuous delivery. But it is becoming more popular. I've seen it a lot in the e-com space. Probably the poster child of all of this is Etsy.com. They release 30 times a day on average, sometimes more. They have entire processes around it. They have delivered papers and talks on it as well. My personal record, I've done it 5 times in a day. And I'm not including any of the, hey, the site is down, let's just do everything in prod so we can get it fixed. I'm talking about feature development where it may not have been planned that that feature was definitely going on that day, but the feature was ready, it was tested. Let's put it in production and see what impact it has on our users. So just to talk through some of the benefits, I mean, why would we look into doing this? Shortening the amount of time that it takes from an idea to happen in somebody's head to getting in front of the customers, especially industries which are driven by user interfaces where, kind of the constant tweaking, there's always the story about Google trying to get the right color blue. The faster you can develop and iterate on a website or on a software product, the faster you can figure out if you've got that formula right. You can experiment with things and do things more concurrently. If you have a release process where you're boxed in, okay, we have every 2 weeks we're going to release something, you have to also figure out, all right, what are we doing in those 2 weeks? If you allow the features to kind of naturally evolve and they're ready when they're ready, you can actually do a lot more concurrently because you're saying, well, we're going to work on this project for now. When it's done, we'll just push a button and it goes out the door. And probably the other thing is delivery becomes a non-event when you get to continuous delivery. You've automated so much that it's not weird to do a delivery. You're not on a call for 3 hours in the middle of the night because you don't want a site outage with your customers. You're just thinking, I'm just pushing a button. If it doesn't go well, I push another button. Problem solved. But what keeps us from doing this? Delivering software can be very painful. I think most of the folks that have been doing this for a while have been on those calls where you're on for 3 hours, you're trying to get the thing out the door, it's broken, it wasn't broken in QA. So moving software from a development environment to a production environment, that process can be difficult. A lot of things can go wrong. So, looking at the list of all the things you have to cover, a lot of times you look at that and it's like, that's going to take me a full 3 weeks to make sure I can deliver something with quality. Well, there's some things that are going to help us deal with that. So here's our release management 101. These are the things that I'm going to be focusing on mostly in this talk. It's mainly about the deployment aspects and the release aspects of software. So we're going to talk a little bit about consistent build processes, having an automated build process. A lot of us have that already. Functional and regression testing. We're going to have some really good presentations later this year on JUnit and Selenium and things like that. So I'm not going to go too deep into what those things are, but where they lie in the release process. We're going to talk a little bit about versioning. Versioning is very important for continuous delivery so that you know what is in which environment. And then, of course, having a deployment and a rollback process. Now, the 501 stuff, this is kind of the more advanced stuff. These are things that companies that have been doing continuous delivery for a while have gotten into. Having switches and things that you can turn things on, where you're pushing dead code into a production environment and then toggling, or having modules where you're only delivering bits and pieces of the software. That's kind of the more advanced pieces of continuous delivery. You have to have been doing the basics for a while before you move on to these things. Having auto scaling, having Puppet in your environment to scale up VMs as traffic comes in. So tools are going to help us here. So we're going to talk a little bit about some build tools, mainly with Gradle. So a good build tool should have some very basic features that help you do those deployment tasks. So dependency management is a build tool must. Be able to package the application together. So taking all the class files and putting them into something that is deployable within a container. Having a plug-in architecture where you can integrate to things easily by just pulling in packages or plugins, such as something to integrate to your source code tool, something to integrate to your JEE container. Having lifecycle management, being able to do it in different environments without having to change the script is very important. And then, of course, again, versioning. We're going to hit on that a couple times. So let's talk about a recipe for continuous delivery using some implementations of these tools. So the talk today we'll be demoing on is a continuous delivery process using Git, Gradle, and Artifactory. In an enterprise setting, you'll probably also have a continuous integration server such as Jenkins or TeamCity involved as well. But a lot of those tasks are just very much configuration driven. There's not a whole lot of coding and there's not a lot of custom things there. So we're going to kind of gloss over that piece for this talk. So let's talk a little about Gradle. So we have a lot of people in the audience that have used it or are using it at their companies. So I mean, it's a build tool at the heart and soul of what it does. It's written in the Groovy language, so you get a lot of things with that for free. Mainly the ability to write a lot of configuration, but also being able to embed code in that configuration in a concise and very readable manner. In my opinion, it combines a lot of the best features of both Ant and Maven together. So I mean, with Maven, I think, has anybody used Maven? Yes? Okay, great. So with Maven, you're kind of forced down a path. It says Maven knows best, and you're going to do it the Maven way, or you're going to have a hell of a time building your software. Gradle's a little bit, yeah, you can do it that way, but if you want to change it, we're not going to bash you in the head. We're going to let you configure it the way you want to do it. And if you don't like it, go ahead and write your own code to do it your way. We're not going to make you write a plugin. You can write it right there in the script. With Ant, you get that same level of customization, but you're still dealing with XML files. And if you want to do something sophisticated, you're still got to do a lot of due diligence. Put together a manifest file, an XML file to say what the tasks are, and then write the plugin code. So even with Ant, there's a lot of pieces, and Ant has no opinions. Ant says, yeah, do whatever you want. So sometimes it's kind of best to have a little bit in between, and Gradle gives us that. So Artifactory, who's familiar with binary repositories? We have some folks? Okay, yeah, this is probably the piece of the puzzle that most organizations are not really using very often, but it's one of those things that can give you a huge benefit if you're doing very rapid software development. Artifactory is just a simple J2EE app, so I mean, you can spin it up in Tomcat or any kind of compliant container. And what it does for you is it gives you a place to push binaries just like the ones you're downloading right now for your Maven or your Gradle builds. So the convention that you have where you provide a group, an artifact ID, and a version number, you can use that for your own software as well. So providing a group and an artifact ID for your own versions and managing your own internal proprietary conventions, Artifactory helps you do that by serving as a local repository. It's also a good thing to have because Maven Central goes down every once in a while. And it's kind of a good thing to have that stuff cached locally. It supports both Ant and Ivy formatted repositories. I don't know if there's a ton of people using Ivy format for the repositories, but it does support both formats, so you can mix and match however you want to do it. And then Git. So Git is a source control tool, one of many that people are using these days. The big thing that it's very good at, and the reason I selected it for this talk, is because it's very good at creating branches and merging. So one of the things that you end up doing a lot of when you do continuous delivery is merging things together. SVN does a pretty good job of merging as well, but Git has more options and more ways to do the merges, and it will accomplish the merges more seamlessly and with less human intervention in most cases, from what I've seen. Kind of the downside of Git is it's a little bit more of an alpha geek type tool. You actually have to know how it works because it is extremely powerful. Whereas with an SVN, you can kind of figure it out without really knowing the internals of it. But it also is a little bit newer, kind of needs a little bit more tooling to it to be, kind of that dumbed down, easy to use. It's getting there, but for continuous delivery where you're constantly merging, it is probably one of the de facto tools that you can use for that. So we've just listed off a bunch of different tools. So how does this stuff actually work together in an environment? So as far as steps are concerned, a continuous delivery process can kind of be broken down into a couple different phases. So I mean, if you have a QA phase, you're going to have to do releases to your QA team for them to test the software. You're going to have a build to get that done. You're going to have tests that run to certify that build to the QA team. And you're going to have to do deployment and verification in that step. From there comes, the release builds, or you can also do promotions depending on how you want to do your CD. So in a lot of ways, if you have a QA process where you can just take that artifact and promote it up, that's usually the best case, because then you're testing the same exact code that you deployed to QA in your production environment. But if you're doing some very rapid iterations, a lot of times you'll have features that are ready and you're not going to stop the bus and say, okay, now we got to pull all these things together because we're going to do a release. We're going to move it to QA and move it through the life cycles. So sometimes I've seen it where they've done integration at a release build, and then that is kind of, we've tested all the features independently in the QA environment. Now we're going to do the integration test in the staging or production-like environment, and then we'll promote up from there. It kind of depends on whether you want to move the software through quicker and how much confidence you have in those feature builds. If you're constantly merging things in from master and reintegrating in those feature builds, you might think that integrating everything together and doing another build in QA and another round of testing may be a bit wasteful. So you do another build for the staging environment, and then you have kind of an accelerated launch from there. As far as the systems are concerned, I'm losing my, did I lose my JavaScript? There we go. As far as the systems are concerned, so you have kind of this feedback loop between the systems where Gradle's kind of sitting in between. Again, we want to automate as much as possible. So Gradle is, downloading dependencies in order to do your build. It's then checking, first it's checking out from your source control, downloading dependencies from your build. Then it's potentially checking things in if you're incrementing version numbers automatically. And then pushing artifacts up to Artifactory. So you have this loop that you go through in your software development cycle. So I want to do a brief aside on versioning, because I think this is one of those things that often gets overlooked. Everybody probably has a version number on their software, but I don't think a lot of people do versioning right. So there's a link that I've put in at the end of this presentation on semantic versioning. And that paper talks about the kind of versioning that's used in open source, where essentially you have 3 numbers. The last one on there is kind of my add-on for that I like to use for continuous delivery. So you've got your major release. Major release basically says we're doing a rewrite, or there are going to be some significant non-compatibility issues if you are integrating to our library. So you have several breaking changes, things that are not going to work. Minor release is the second digit, which means you're probably going to have some compatibility issues, but you might be lucky. You might be able to use this piece of software with your current stack, and you might be okay, but you probably need a pretty solid regression test. The third number is patches. So patches are basically bug fixes, small things. We're not really adding features. We're just kind of fixing things that were broken, making things faster. You should not have to really touch your software at all to take this. This should be seamless, is the patch. So using semantic versioning within your organization can really help with trying to communicate to people, because I mean, we all know release notes. It's all right, we're going to write down everything that changed, but that may not communicate out to the people that are using your libraries that they actually need to do anything, because that may be meaningless to them. With the semantic versioning, you can kind of demonstrate that to them. If you're using like an OSGI container, that actually has meaning in how the different bundles interact with each other. But that's for another talk. The feature branch kind of addition that I've added on is one of those things to help with the QA process. So when you're doing continuous delivery, you'd end up with a lot of branches. And it makes versioning harder because, well, which version are we really talking about here? Because we could be going with this tomorrow, or this other thing could be going first. So adding the branch name to the end of the version gives us a way to add some traceability to an artifact we may be deploying to our binary repository to say, we built this on this feature branch. So as that gets tested, perhaps in its own environment, if you're doing split environments for features, you kind of know which binaries are associated with which feature. So when you're using Maven or even Ivy, you've got this concept of a classifier, which is what that fourth thing is called in those conventions. I had a very interesting conversation with Hans Doctor at Java 1 about the usage of snapshot and how that typically gets overused, and how by using snapshot you're essentially timestamping all of your artifacts, and how that doesn't really trace back to what you're doing with your software. Because I used to love snapshot. It's like, this is great. I just push the button. It's the same version. I can deploy it. And it always just is the most latest thing. But again, if you're trying to get traceability, if you're trying to get the process more under control, it's better to actually use that fourth classifier for something significant to communicate about what you're deploying. Question, yes?
Would you ever see a case where you use the feature branch name and snapshot in conjunction with each other? So like if the feature is under active development, you may have multiple releases.
Mm-hmm.
What's your opinion on that?
Yeah, so I mean, the interesting thing that they stated is version numbers are cheap. Why not just increment the version number than use the snapshot? Because again, there is nothing that guarantees or traces that code back to a commit or something that you've done to the repository or to your source code repository. Using snapshot, I mean, they basically equated it just to kind of being lazy, and that's probably one of the reasons I liked it as well. I mean, you don't have to think about it. You're doing your deployment and you just say snapshot, so I'll just take the latest. There's I think other ways to increment the version number. Again, the version number is very cheap, and being able to target the latest or the highest number by querying the repository. And then you save some of that context to say which one is the latest, and have some traceability back to things that have changed. Good question. Any other questions? Yes?
You mentioned earlier that the patch version is typically just a bug fix and nothing.
Yep.
So in this case, if I were to going back to your previous slide where you had the merge,
Mm-hmm.
you then does that indicate that we would get an increment of the minor version then to add in these new features?
No. So I mean, for a patch could be. It could be a very small feature, but it shouldn't ever impact people that are currently using it. If you look at the open source model, some of the that are out there, Jackson's one of them that I think about, where they'll sneak little features in, to the patch releases, but they don't break anything, right? I should be able to go to 1.0.1 to 1.0.5 without really having to worry about what it's going to do to my stack. Doesn't always happen, but again, conceptually, that's how it's meant to be thought of. I could be doing it to get an additional feature, but they should be non-breaking changes. So often additions are non-breaking. If you remove a method from an interface, if you change the signature of a method, that's a breaking change, and that could even, that's going to at least increment a minor release. Does that make sense? Yeah. Okay. All right, so enough of me being up here waving my hands. So let's take a look at some code. Let's take a look at how Gradle can help us do this process that we've been talking about. So for this demo, the internet here is kind of slow, so I'm going to do it all locally instead of pushing it out to the web. But I did have a web demo. And all this source code is going to be available. It's all on my GitHub, and as well as this presentation. The three plugins we're going to be using is the War plugin, the Cargo plugin, and the Maven plugin. So just most people understand kind of what the War stuff is about. That's just packaging the files together in the format that is the spec for web archives. But the Cargo plugin is a plugin that helps interact with containers. So a lot of folks are like, well, okay, so we've got to deploy the War file now. We've got to spin down the server. We have to move the file. Cargo does that in a more seamless way. So Cargo actually is implemented in a way that if you're running Buddy, if you're running Tomcat, if you're running JBoss, it has connectors to those management interfaces, and it will deploy your War for you without necessarily having to turn off the web server. Now you can still run into class loader issues if they are holding on to classes and not correctly dumping those things out of memory. But as a convenience, it's a very nice plugin to be able to do that kind of on the fly. And when you don't want downtime, it can kind of help not having to spin down those servers. The Maven plugin is in there to help me interact with Artifactory. So when I publish these things out to the binary repository, I need to tell it what the dependencies are, what the version number is. So the Maven plugin allows me to do that in Gradle in a Maven format. By default, Gradle uses most of the Ant functionality under the covers. So Ant is kind of like a first-class citizen in Gradle. So pretty much any Ant task you can think of, you're already hooked up to in Gradle. So Ivy format you can do by default. I'm partial to the Maven format. All right, so probably one of the most important things and coolest things that you can do in Gradle is being able to take code and mix it in with your configuration to give you some really dynamic possibilities on how you put together your build script. So here's one example of that. So here's how I've configured my Cargo plugin. When you look at Maven and Ant, you can have variables and things that hold values that you've sent in from command line. But here I'm actually able to derive things on the fly. For example, the port numbers and the host names of my different environments are going to vary. And you never want to hard code those into your build script. I know we do sometimes just for simplicity, but being able to put those in properties files and be able to store those on servers can give us a lot of flexibility in how we write our script. So now I can write it in a very generic way and pass in the environment number as a variable and then get to those properties so that I can set the host names as I'm running my deployment. Again, don't embed those things in the scripts. It's very easy to do. One of the things that I really liked, probably one of the only things I really liked when I was playing around with LifeArray, is how they did some of their user properties files for their open source builds. Basically defaults to your username on the system you're using. So if my username is bpaulin, bpaulin.properties, I put that in my dev folder, in my build folder, and then I can set all my custom properties instead of hacking theirs and accidentally committing them up. Having these things that you can exclude from your check-in process are very helpful. All right, so dependency management. In Gradle, it's a little bit different than both Maven and Ant because you maintain both your application build properties and your build script dependencies. Because again, since you're able to write code right there in the script, you can import things just for the script that are not going to your application. So here's an example. This is what my build script libraries look like. So I'm using the cargo plugin, so I have this Gradle cargo plugin that I'm pulling that is not going to be packaged with my application. It's simply for the build script. The same with the Gradle Git integration. I'm just using their libraries to call Git commands from the script. And then my war file dependencies. So just like with Maven, we can set different classifications. So exclusions, we can set whether things are test and compile only, whether they're going to be provided by the container or not. And another cool thing that you get by proxy from it being Groovy is you have this, this concept where I can just inline do string replacing using the expression language. So I can set my version of WRO4J or my version of Spring, and then I'm just including it as an expression, as a $ expression, where it's going to be replaced. Again, there's ways to do that in the other build tools as well. This is very shorthand. I mean, it doesn't take up 4 or 5 lines. It's one line, and I can put many dependencies on each line. So now tasks. So this is probably another one of the most flexible things you can do with Gradle. So you don't have a plugin that does exactly what you want. It's not a problem. You just write your own tasks to do that. And there's a couple of different types of tasks, ways to write tasks that enable you to do this. This is your standard task. This looks a lot like either an ant. It can look a little bit like an ant task. You can set what the dependencies of that task are. And then inside of that, I'm just writing code. So inside that's just Groovy code. This specific one is looking for my task hierarchy. And if I'm using a release build or a QA build is my other target, I'm appending the name of the branch to the QA build. With my release build, I don't want that on there. I'm just going to use the standard three-digit version. The other type is a lot more shorthand. So I'm using the Git integration, the Gradle Git plugin. These are called task types. So here, I'm not actually writing any code, but I'm taking one of their plugins, and I'm configuring it and giving it a name. So the task that I would use to tag my release. So I usually would want to tag my release so I can get back to it when I'm doing a production release, so I know what the source code looks like. Here I'm just providing the version number and as the name of that tag and a message. So I can just provide those things fairly easily instead of writing a whole bunch of code, client connection code. All that's behind the scenes for me here. And then linking things together. So again, if I have an entire process that I want to run, I can start chaining dependencies together. Now, one of the really interesting things that happen that if you're just getting into Gradle, so looking at this, which one do you think runs first? Do you know just by looking at this?
They run in parallel?
They can. That's kind of the trick. Gradle does not tell them exactly what order they run in based on the depends clause of any of these methods. It's kind of one of the things that they have kind of taken a bit of an opinion on how they've designed their build script. And I think the reason they do that is they want to be able to run a lot of things in parallel. The idea is that you would have a build process where you'd have multiple things going on at once. Now, of course, you can structure them in a specific order, and that's by using task dependencies, but you have to tell it a couple of times. So here, I can define which things require some sort of order to them by using must before. There's also a statement called should run before, where it's more advisory, but if you run into conflicts, it could break those constructs. I generally just use the must run before where I need that type of structure. But it will try to figure out what those dependencies are. But you will, if you don't put these things in and you have a custom clean task, your clean might run after the build. You just have to structure those things. All right, so demo time. So a simple book review website. So let's run through what scripting might look like in this case. So up here I have, oh, that's the internet version. We're not going to use that. So here we have a website. It's running on Tomcat locally. It basically just shows book reviews. It integrates to the Google API for books, and I can enter in different search terms and click and add reviews for that. Now let's say I wanted to add a feature. So the business comes in and says that I want to build some feature that allows me to generate a rating score based on the average rating from Google and then the number of ratings that they've had. So let's see here. I'll save you my typing. So I actually have made all the changes required in another branch. So I'm going to use, I do like the Eclipse integration that they have. Oh, I am in that other branch. So I'm in my ratings branch. So your master branch is kind of your core branch, your production branch, and then you create feature branches based on that branch. So here I have a ratings branch. And basically all I've done is I've taken some code that looks at the ratings count and the average rating. I brought that in, and I've done a calculation for rating score, and that's going to be then run on the JSP page to show that rating score. So what I'm going to do first is I'm going to run a QA build. So I'm going to run that same QA task that I was running before. And I mean, basically what that's going to do is it's going to get my branch name, it's going to run a compile, it's going to run a build, and it's going to package the application together. Hopefully it can resolve these dependencies quickly, or else we'll just deploy it straight from Artifactory. We're testing our classes. So how many people have built APIs like this? You go out to Google, you just kind of type in the URL that you're expecting, get back a JSON. OK, my stuff is there, and it works, right? That's how it's supposed to work. All right, here I've got my version number. So that's my next version. It's always nice to have a build script that automatically increments that version number for you. If you have to check out, check back in, push things up, I always forget to do it. All right, so at this point we have a artifact in the binary repository. So now my next step would be deploying it. So here I'm going to do a clean. I'm going to download it from Artifactory, and then I'm going to use cargo to push it out to my local running of Tomcat. So here I have to enter which version it is. So we just built 1.0.2 ratings. So now we're going to that's going to download and deploy. Now, if this was a production website, we would expect this would go through, and we've coded it, we've done a round of QA, we've used our QA databases, and everything's supposed to work. So let's take a look. Uh-oh, we just broke prod. What happened? Well, the API said that they were going to have ratings every single time, right? Maybe not. So what can we do here? Well, if we're continuous, if we're in our normal deployment, we've already been on the call for 3 hours. Do we need another 3 hours to back this out? Are people going to be able to buy stuff on the site now? Uh-oh, we're in trouble. But if we've done our continuous delivery, if we've thought about rollback, we're able to fix this very quickly. Okay, shoot. We've done our deploy. Why don't we roll back to the last release that worked, and then at least people can buy stuff on the site again. Okay, let's go back to 1.0. Rolling back. Uh-oh, Tomcat stopped. We'll restart Tomcat. This is the class loading issues I was talking about. If you deploy too many times, you run out of space. PermGen's dead. All right, let's run this again. So prod was down anyways. We didn't make it any worse. But having thought about rollback prior to actually running into a problem is a very important thing that usually we don't think about until afterwards. And having it automated is another key thing. Rolling back should be extremely fast, because one of the main arguments that Etsy uses for why they deploy so often to prod and why they have this process to begin with is because none of their environments are like prod. Prod is always, in most companies, it's special because you have your cloud deployments. Your CDN is up there, caching everything. You don't generally have that in test environments. Some companies can afford that, not everybody can. So having a unique prod environment, the only way you really know if it works is by deploying to prod. And the faster you can do that and the more quickly you can do that and then roll it back, the better off you are in order to get your site back up and running. All right, we're back. Any questions on rollback? Yes?
So do you have any advice if you're working in a clustered environment, let's say you deploy the version of multiple Tomcat servers
right.
Back, like, do you have any experience actually doing that with Gradle and the Cargo plugin, or is that a little bit more?
So I have done it with Cargo, not with Gradle. So I've done it with Maven, where what we'll do is we'll use a VIP and we'll split traffic so that half of the data center is serving the traffic, and we'll do the deploy to the other one that's currently not serving traffic. We'll test there, and then we'll flip it to deploy to the other. So I mean, if they're all clustered together, they should be redundant, and that should be completely seamless, right? So I mean, if you have stateful applications, you could still lose sessions, but you can kind of wean traffic down to some of them to where there's no live sessions, and then eventually, you're not going to break anyone's stuff. Yes?
In this example, in order to do the rollback, you have to know what version that you should roll back to.
That's right.
How would you recommend keeping track of that?
Well, so it could be notepads. What I've done in the past is, especially in like a web-based application, it's nice to have like a little Easter egg page that tells you what version is running when you hit the server. It could be just version.html page that it deploys out with the application. And knowing what that was before. The other thing is, if you're using a CI tool such as Jenkins, it may have that information in there of what the last deployment build to production was. So you can look back at the last build job that was successful and roll back to that. You do need to know which version you went back to. Yes?
What are your thoughts on automatic rollback?
I think it's a necessity. Having something in place that you can do it quickly. Now, are you talking about having automated tests that will roll back the software if it fails, or what do you mean by that? Automatic, where there's. Yep. Okay, so that's a little bit more sophisticated. I mean, you should have quick rollback, but having automated rollback is a little bit more challenging. So if you're in the web space and you have Selenium, one of the great things about Selenium is you can do automated testing with it in the browser. The bad thing is there's often false positives if you're trying to do something sophisticated. So if you are going to do a web-based automated rollback, you kind of have to build in for those false positives. So I mean, you can't completely get around saying, okay, nobody has to look at it, because you may roll back when indeed you don't have to, or you may still even miss something, because usually those tests lag behind the production code that's being released. So I mean, it depends on how stable your software is. I mean, if you know if these 3 things fail, we need to roll back immediately. And you know, some of those things could be heartbeat type things that, hey, if I get a 500 back from this, we're dead in the water. That would be something that you could put in an automated rollback. But you know, I wouldn't recommend running an entire Selenium suite and basing it off of that. Is that what you're asking, or? Yeah. Okay. Yes?
Well, I think we should also realize that even if when production fails, your first response is to roll back the latest changes.
Mm-hmm.
But there are definitely cases where that won't fix the problem, because like AT&T certainly showed us when their 800 service failed a couple of years ago. There was a bug in the code.
Mm-hmm.
The bug had been put in there like several months prior. It just didn't show up.
Sure.
So they couldn't find an old production version that would work.
Right, yeah, I mean, some of that's, I mean, so having that full binary repository where I could go back 8 releases if I wanted to is one of those things that can help you there. Now, when you talk about going back 8 releases, that's a little bit tougher, because if you have dependencies on it, that suddenly can become a problem, because other software systems are expecting you to have these features, and suddenly those go away. So now you've got a little bit of a problem. But having those releases to put back in a test environment to at least say, okay, well, you can go back until you find one that works, can be extremely helpful versus not having that at all. You know, there's a multitude of things that can go wrong in production. I think the point I'm trying to make is the more quickly you can move code out there and the more automated and more frequently you can do it, the more you can minimize those things that creep up like that from time to time, because you can react quicker.
Git actually has a really good built-in tool, Git bisect, for
Mm-hmm.
Yeah, if you have automated tests, they can identify the issues.
All right.
One more question.
Yes?
How do you try to manage database changes? So you don't speak about database, but sometimes when you have release, you could have, a lot of database structure and
Sure.
changes like that. And how are you going to roll back it?
It depends on what they are. So with all these things, a lot of times it depends. If they are destructive changes, I just removed a column, I removed a table, I changed a name, I changed a field length to be shorter where some of the data is not going to fit. Those are destructive changes. Destructive changes make rollback more difficult. So it's very important to keep those in mind. And if you can design your software so that you don't do very many destructive changes with your releases, you're more able to roll back. Because if I just added a column to a table, and that column is optional, and I roll back the software, and it's running on that old database, that's a non-issue. Being able to script adding that column in as part of deployment, that's not too bad.
Yeah, but I'm not talking just about DDL changes.
Mm-hmm.
Let's assume some DML changes, like you upload a lot of static data.
Sure.
So, and because of that static data, some business logic just stopped working.
Mm-hmm.
So, what are you going to do? So, are you going to write the script which will remove all the new data uploaded, by the script, or are you going to have the run, like some scripts which bring environment from nothing to some previous state? What is the best practice? Because when you have a regular deployment practice, like once in 2 weeks, so you have some scheduled and decided solution for that.
Yep.
So now you say that everything should be very quick. So what kind of best practice solution for that?
Well, I still think it comes back. So it comes back to destructive versus non-destructive. If your data, even if it's not a schema change, you have sent the data in one direction and you have no way of pulling it back, in my mind, that is a destructive change because you're doing something that you can't revert. And if it's critical, would I write a backout script for that? Yeah, I would consider that. I mean, because if you're doing deployments frequent enough, you know, that's a piece of rolling back your software, right? Yes?
The other note I would say is there are migration tools like Liquid-based that would allow you, like let's say that you're inserting 500 rows, you would have an insert operation and a rollback operation where you would be deleting specifically those 500 rows. And so if you roll back to the previous version of the database, it will actually apply that delete operation. And Liquid-based will keep you somewhat disciplined about making sure that for every uptick in a database revision, you also have the inverse operation that's also previously defined and tested.
Yep.
That's the thing, you will just
What?
return to snapshot.
Yeah.
Well, no, so when you're storing a database snapshot at that point, you would actually be, like, let's say if I have in my script insert these 500 rows with these primary keys, you would have, as part of that same migration definition, deleting those same 500 rows. So if you need to go back a version, then you execute the inverse operation.
Yeah, that's like, in our company, we do it that way where we actually have upgrade and downgrade scripts where we, you know, when there's, you know, if there was business logic that changed. But sometimes what happens is you don't see the problem until 2 days later when there is new data already in new databases and new tables.
Right.
So when you roll back, then it's not just restoring database, it is a downgrade script to just reconvert the data to the previous format.
Yeah, and I mean, even some of the, so even Etsy is really, their database changes, they don't do those daily. They'll tell you they've got a day of the week that they do those. So I mean, a lot of it comes down to a design problem. You know, how can you push the code out in a way that it's ready to accept those database changes when they are active if you're going to only do database changes once a week? Because it does come down to, you know, can you design, that gets more into the toggling, right? So where it's, all right, so we're going to have this column and that column's going to become active a week in the future. We're going to push the code out there that works with it, that we've tested in the QA databases. The database push is going on Friday, and then we can flip that toggle on. But having the software where it's backwards compatible to the old schema and the new, and then but able to adapt to the new schema is one of those really fundamental things if you try to get into this, you know, multiple times a day. So yeah, we saw our oh shit moment. But again, knowing your rollback strategy and having a deployment process that is separate from your build process. So many companies have it where, okay, well, we need to roll back, but we got to do another build. You should never have to build your software to do rollback because there are issues that you can run into if you have different compilers. I mean, recompiling the code is a risk. And it's a risk you don't need to take as if you have a binary repository, you're holding those releases. So always separating your build and deploy process into 2 different phases is really a critical thing to this. And it's a very common mistake that you see in release processes. All right. So what would this look like in an enterprise setting? So as I was mentioning before, you know, usually you'd have a lot of the stuff that we're talking about with Gradle wrapped in a CI server. So you've got Jenkins kind of managing all this process together. You know, Jenkins is running the script that's publishing things to the binary repository, downloading the dependencies and managing the source control tree, doing the checkouts and such. You know, the line between what should Jenkins be doing and what can Gradle be doing, it's actually quite a gray area because there is a lot of overlap in the functionality. But it is kind of nice to have it in the build script because then if I want to experiment with, if I want to test it locally, I can do that. And with Gradle, I could write unit tests for my build if I wanted to verify that the thing works exactly how I expect it to. That's one thing you can do with Gradle that you can't do quite as easily with other build tools. So now just some parting thoughts. So you know, how many people, I'm just kind of curious, have a separate build? And so actually, how many people currently deploy more than 5 times a day? Nobody? 2?
QA or
Production. 2? 1? More than, okay. How many people deploy once a week? No, once a week or more often. Okay. Every 2 weeks? All right, so that's the Agile folks. Every month? Every year? I saw a lot of hands up for, hey, we're doing continuous deployment. Is there a reason why you guys don't deploy more often if you have if you are trying to do this, or is it you're kind of, what's that?
My software works, and I don't have to.
Oh, okay. So you don't have to. You wrote it right the first time. Does anybody have any comments on that? On why maybe we don't deploy as much?
I think one of the challenges, like we're in a consulting business, so oftentimes the QA and like the people that sign off are external to our company. And
Right.
so, like they have a time where they're giving a heap of features and rejecting or accepting changes.
Yep.
So it's more of an institutional bottleneck than anything else.
Yep. Anybody else want to? Dittos. Yeah. It's those clients, man, they get in the way. We know it works. All right. Well, I'd like to thank you guys for your time. All of the slides are up on my GitHub account. Here's a couple of links for folks that are looking for more, just links to the different plugins. Some of the stuff that I was looking at and when I was building my own plugin was based on the Maven release plugin, which there's a Git release plugin that is in dire need of some maintenance. So some folks that may be interested in building on some already pre-existing release code, I know the guy that runs that project is looking for help. Also linked to the Etsy talk from, what was it? They're at GoTo recently talking about their process. Some very interesting things in there for kind of that 500 level deploy or continuous delivery stuff. So.
They have a three-part O'Reilly talk series as well.
Oh, do they? I did not know that. Okay.
It's all DevOps, but really interesting stuff.
Yep. Yeah. Oh, more questions. Mm-hmm. Yep. So having integrations to things that can spin up environments in a consistent manner like Puppet or Chef, I mean, so those are scripts that you can kick off from a build script. Doing an environment where you have auto scaling where, oh, we're just taking a bunch of traffic and now we need to add more servers is kind of outside of what I was looking to get through in the talk. But there are other products out there that can help you scale up like that. Also, having a cloud deployment, that can help if they have auto scaling involved. It all just depends on how you want to put together your infrastructure. So there are options to tying it into the build script, but usually you don't do those things at build time. Really when you think about putting new environments together, that's more of a deploy and real-time thing where things are changing and I need to add more boxes.
Well, last question.
If not, I can talk afterwards. So.
Just a question. So, do you have any UI tools? Because if you are talking about many deployments every day, so it means a lot of interaction with the business representatives. So why don't we let them to monitor and probably deploy some versions? So I mean, like Bamboo, if you know, you can just set up scripts which do builds and deployments.
Yep.
On the user-friendly interface.
Yeah, Jenkins can give that to you. I mean, we had folks at director level at some of my clients that they did the deploys. We didn't have, again, getting it out of the hands of the developers and into the hands of the people that are kind of, the buck stops with them. So, you can have the CEO deploy from a Jenkins script if you want to. It's just pushing a button. So, all right, thank you.